Making snap-together injection molded parts, Part 1. Welcome to another episode. In this episode, I'm going to do a few things. First, I'm going to show you a little bit closer up some of the details of working with the Haas. But mostly I'm going to be focusing on making an injection mold that allows me to have some snap-together parts. And these are fairly small parts, about this big. So there isn't a lot of room for a snap mechanism. And quite often snap mechanisms either require an undercut because you've got something like a taper like this that goes down to the flat surface that is hard to injection mold, or another mechanism. I'm going to use tapered pins. So what I'm going to do is take you to the computer and show you the design and then show you the mold that I've designed for it. And then we'll go ahead and make the mold and make a couple parts. This is a two-part series. In the first part, I'm just making the piece that has the tapered pins. In the second part, I'm going to make the mating piece that the pins should snap into. Here's what I'm trying to do. Make these two pieces such that they snap together. Let me grab onto this and give you a better idea of what's going on. So this piece down here on the bottom has a taper which would cause an undercut. So you can't injection mold this normally. The part on the top has a draft down here which is a little bit more than the draft at the top. The draft here matches this face perfectly, whereas the draft down here results in this opening being slightly larger than this, so that it will guide this in, at least that's the idea, and allow it to push past this point here because of the deformation of the plastic. And then once it makes it all the way through, this surface here should keep these two parts tightly together. That's the theory anyway. So what I've done, let me undo that and get rid of this thing here, is I've created a mold, and let me go back to this piece here so you can see how it fits in. So the mold is a multi-part mold that has the typical core and cavity, but it has these two inserts in the middle. So let me get rid of this part here, and let me go to this view. So you can see that there are two parts here, and I'll hide one of them. And what you can see is that these have a tapered opening that allows me to mold this tapered pin. And then these two parts will basically slide to the sides to allow me to remove this part. What I'm going to do now is head to the machine and start milling these parts and then injection mold a sample. This is a little bit of a dodgy setup because these are so narrow. I will actually make them quite a bit wider in the production version, but for now, it's what I have. What I'm going to do is use the right side to cut these to the correct width, because these need to be 0.75 inches for both of these. And then once I've done that, then I'm going to put just one of them in the center and do the rest of the milling, because for the rest of the milling, it doesn't need to be near the edge. For the zero position, I'm going to use the top of the parallels and then the back left of the part. Here I'm using a contour with multiple roughing passes to cut this to the correct width. When I cut this out on the bandsaw, I cut it about 0.1 inches wider than it needed to be, and so this way I can cut it to the exact width. I took out one of the pieces and then put the other one back in centered, tightened it up, and then all I needed to do is to pick up the left side because the bottom and the back were the same as before. The bottom is very simple. It just has two features, the alignment hole for the alignment pin, and then the other feature it has is the runner, which is just a 1/8 inch diameter hole that goes down to basically a ball end. So here you can see cutting that. The top side has most of the details. I start with a roughing pass using a 1/4 inch end mill, and this is going to cut out the majority of the material on the left side, as you see here, as well as the right side. Next we have a 1/8 inch ball end mill, which I'm using to cut from the top down, to make the slope sides on the right as well as the front and back very smooth, so when the parts fit together there won't be any catching because of sharp edges. Next is a 1/16 inch diameter ball end mill, and this is to get the lower parts of the slopes that were too far down for the 1/8 inch ball mill to be able to get them. So this operation is using rest machining to cut those remaining pieces. And finally we have a 1/16 inch diameter flat end mill to again go down with rest machining and to remove the bits that the 1/16 inch diameter ball end mill weren't able to reach. Okay, so there's a little bit of chatter in a few places, but I have a pretty good idea of how to fix that. So I'll fix that for the next version, but you can see we have the tapered slots here that will be used to mold the pins, and then this is for alignment in one direction, and this is alignment for the other direction. Here I'm cutting the cavity section to the correct width with basically a roughing pass and then a finishing pass. I switched from the 1/4 inch flat end mill to a 1/16 inch ball end mill. This is currently running at 30,000 RPM, and you can see when it's at certain positions the coolant hits the end mill, and because it's spinning so fast it basically produces a fog. Now if I run this for too long the fog ends up in my room, and that's something I may need to get a mist away or something else to pull out the mist and filter it so it doesn't end up in the room. Here are the two parts that I just made. This one was a little bit dodgy, as I mentioned, because when it was in the vise it had the ability to move a little bit since I didn't have enough along here to make sure it was square. So I want to see how it turned out if I put it on here. So this way there's very little movement, which is what I want. This way it is flush with the edge here, which is what I expected because this is where the edge finder was. But over here I can feel a little bit of a bump. So I'm going to get out the depth micrometer and see if I can measure the difference in depth. Alright, so I'm pushing this up against the shoulder here with my finger, and then what I'm trying to do with this right here is pick up the edge where the two meet, and then I'm pulling back and then pushing really hard so that, there we go, I can feel when I start to get some resistance. And it feels like it's at about 4 thousandths. So what that is telling me is that the lip I have on here is 4 thousandths of an inch. So when I make the other piece and make it perfect, it may mesh up or it may not push together. I'll find out. What I'm going to do though is change the cam strategy that I used for this one. So for this one what I did is I started on this side and I milled this to width. And then I flipped it over, which means I lost my alignment. So it was no longer necessarily perpendicular. What I'm going to do the second time around, it's actually going to be a mirror image of this, but I'm going to pretend that I would do this one again. So what I would do is start on this side with this a little bit long, and then do the roughing and then finishing pass on the wall here. Do all of these features. So now this edge and this edge will be aligned perfectly. And then I'll flip it over and do this feature and this feature. Because these are going to be so close to where I put the edge finder, even if this is off a little bit, it should be fine. So that should give me a much better part. And as I say, if I need to, I will remake this one as well. I'm going to set this up for the doing the other side. And for a spacer, I'm going to use the one that I already made. So I have to make it wider. So I'll put this over here, and then I'll put this blank piece over here, just making sure there are no burrs. And one of the things I realized after doing this one is I can use the Heimer to pick up this edge. Actually, I should take, yeah. So I've already faced out this edge. So that means I can pick up this edge with a Heimer and make sure that it's square to the vise. So I'm going to put the Heimer in. Okay, I figured out the technique for getting this parallel to this edge here, or this axis, which is I pick up the edge here and I set the 0 on my display. And then what I do is I pull this over so it's not touching, because otherwise it can drag and deflect it this way. And then I'm going to move the Y to the other end and then bring in the X. Set the Heimer to 0. And then I look on the screen and it's showing that I'm within 4/10 from one end to the other. So that should be plenty good. All right, the moment of truth. I now have 2 parts, so let's see how this fits together. There's one. Oh, yeah, that reminds me. I made these too long, so I'm going to have to cut this short on the bandsaw before I can test this out. So I'm going to actually cut both of these short, so I'll be right back. All right. So I've got them cut to length. My plan had been to basically assemble the mold and then mill it flush, so all the parts would be flush. But when I milled this, I didn't really think it through. Okay, so let's see how that fits. What I can see is that there's a gap there. We put this new part in just by itself. Okay, so I'm not feeling the difference I was before with the other side. But when I put them together, you can see that it's kind of what I expected, which is that these don't actually fit down all the way. I want to trim the faces off of these 2 parts here. And I decided to see if I could use G54 and G55, basically 2 offsets, to be able to do this with one program on the machine. So what I have here is this is going to be on the left side of the machine. And you can see I have the coordinates in the back left. And then this one is going to be on the right side of the machine with the coordinates also in the back left, but facing off this face here. So what I did is went to the NC tab, or the post-process tab, and then I changed this first one, which is the one that's going to be on the left, to be work coordinate system offset 1. And for the one that's going to be on the right, I set it to 2. And what that will do is when I select both of these and then right click and say post process, it will save these as a single file that has both G54 and G55. I do get this message here, which I just ignore, and then go into here and then save the file. I'm going to try something here. So I have these two parts in here. And what I want to do is I'm going to use G54 for this, G55 for this. And I'm going to basically skim across the outsides with a 1/4 inch end mill. I have a theory that maybe the end mill I was using wasn't the exact diameter, and it's kind of hard to measure because it's a 3-flute end mill. So I just want to skim this, and then I'm going to test it out. So the first thing I'm going to do is bring this in to make sure that this is lined up. And what I want to do is try to use this edge here. Basically come in and pick up this edge, because this edge needs to be parallel to this edge. Okay, so I'll bring it down. What I want to do is bring it down to Z until it just touches, and then back off a little bit. And then I'm going to bring it in the X until it says 0. And I'm going to switch to 1/10,000ths of an inch increments, or thou increments. Set this on 0, and then do mem hand jog, and now this is distance to go is 0. So I'll back off, and then I'm going to move in the Y a little more rapidly to the other end and see how we're doing. I'm going to have to set the Heimer back on 0. And then have a look here. And so it says it's off by 6/10, which that's pretty good. So what I'm going to try doing, I'm going to see if I can make it a little bit better, is I'm going to set this to 0. And I can see it's gone a little bit past. And I can't, so that means I need to bump it that way. So what I'll do is I'll go back to where this is 0, which is close enough. So I'll 0 this again, and then I'll move away from that point, and then move in the Y to the other end, and then I should be able to jog it in. Okay, so this is saying it's off by 8. So I'll now put it so that this says 0. And I can see here this is not exactly on, so I'll give it some taps. I don't want to go past, but there, I think I've almost got it. There we go. So now it's reading 0. So let me come back to the other way. And then Y. And I'm setting Y with a small movement first to make sure it's moving in the second direction, and then increasing the amount of movement to reduce the chances that I break the Heimer tip. Okay, so now I'm at 0 and this says 5/10. Okay, well, I'll say that's close enough. So what I want to do now is pick up the G54 position. I'm going to bring the Z up, and then I can move it a little bit faster. So I've got the 0 coordinate at the back left for both of them. Okay, it's at 0 again. So now I'll go to the offsets page, set G54 part 0 set, and I just updated that. So now what I'm going to do is go to the other part and pretty much do the same thing, but when I do the offset, I'm going to set G55 0. And I want to copy the Y and the Z down to those places. So before I forget, let me just copy the Y to here. So it's minus 1.9248, press F1. And now that's the same. I'll do Z, 3.4905. And so now those match. So now I'm ready to set up G55. So I'll do Z. Now for this one, I can use this side here to make it square with the, or parallel to the y-axis. Because on that one, I use that as the reference point. Oh, I'm sorry. I use this as the reference point, so I need to go to that side. Okay, so this one is parallel to within 5/10, so I'll call that good. Okay, now I'll do 0.1 and then plus Z to move it up and out of the way. And by doing that, I make sure that I don't move it either in the X or the Y direction, which would potentially break the Heimer tip. Okay, so I can put the other tool back in, and oops, what I forgot to do is set that as the G54 0. I have the Heimer zeroed on the X, so I'll go back to the offset page, G55 0, and then say part set 0. So now I've got the two coordinate systems set up, and that means I can load my program that has both G54 and G55 in it. And with any luck, it'll mill the two sides the way I want. What I determined is that the parts are still a little bit too wide, so what I want to do is I want to take G54X and I want to move the 0 position to the right by 1/1000 of an inch. So what I can do is I can type in 0.001, which you can see down here, and then when I press the enter, you'll see that this goes from 10.3107 to, well, you'll see. So now you can see it changed ever so slightly. Now for G55, I want to move it in the negative direction, which is to the left, to make that narrower. So I'm going to make this minus 0.001 and then press enter, and you'll see this change as well. All right, I straightened these two, and then as you saw, I took off an extra 1/1000 of an inch from each side. And now, if you look at this, you can see that it pretty much matches up perfectly on both sides. This side is a little harder to see because I need to mill this to length, which I'll do once this is all finished. I'll put it back in the mill and then deck this side off so it's completely flat. But now it's time to do the cavity, and then I'll be able to do an injection molding test to see how this turns out. Here are the parts of the mold. I have 2 places for alignment pins. I'm only using one because the reality is that I only need to align one of these, and then the other one is held in place like so. So now when this is squished in the injection molding machine, everything is held in place. I mean, when I make a production mold, I'll put another alignment pin in so it doesn't do this. Okay, so let's see what happens. So you can see that this is still in there. And so what I'm going to try to do is pull this out. That separates the part from the mold, and then I can pull these apart. And it's a little harder to pull apart than I expected, but if you see, I have nice tapered pins. So I'm going to make a few more parts, and okay, so same thing, it pulls those out, and then I should be able to I'm going to have to take a look at these. I might need to file them a little bit, but here it's working. The end result of that is I was able to make a set of parts, and they turned out quite nicely. I'll have to... There. So if you look there, you can probably see how the pins are tapered, and they're wider at the top than they are at the bottom, which should allow them to snap into the other part and then stay tightly in the other part. I'm pretty happy with how things turned out. I learned more as usual. The more that I push myself to design things like this and the more that I use the Haas, the more comfortable I become with it. I still make mistakes, of course. This time I did break a Heimer tip, which is why you probably noticed that I was being really careful not to break yet another Heimer tip. So I hope you enjoyed this. Stay tuned for episode 2, where I will make the second part, and hopefully things will snap together. I won't know if it's going to work well until I do that, so we'll see what happens. Please subscribe, give me a thumbs up, comment below, and I'll see you next time.